Okay, in this video, I'm going to do questions 1, 2, and 3 from the test 4 review. This particular one right here is our first question. It says, suppose the function f of x is equal to b to the power of x, and that it contains the point 473. And then we just want to know what is b. So we're trying to find the base, which we sometimes call the growth factor. Okay? If we look at this point here, we know this 4 is an x coordinate, so that's an x. And this 73 here, that is an f of x. That's a y value or an f of x value. In particular, it is f of 4, because if we were to plug in 4, we would get 73. So what we'll do is we'll take the 73 and we're going to put it in for f of x. Then we're going to take the 4 here and we're going to put it in for x. And what we wind up with is 73 is equal to b to the 4th power. This is actually really easy to solve as long as you have a calculator, which I do. We will bring down the 73 and equals and the b to the 4th power. We're going to put both sides in parentheses. And then what we're going to do is on the right side, we're going to take it to the 1/4 power so that we can cancel the power of 4. And if we put the right side to the 1/4 power, we have to put the left side to the 1/4 power as well. And over here, this cancels. We wind up with b to the 1st power, but we don't write b to the 1st power, we just write b. And then that's going to be equal to 73 to the 1/4 power, which we can now calculate in a calculator, right? So we've got our calculator. Let's key in 73 to the power of 1/4, and that gives us 2.923. 2.923. So b is equal to 2.923. And that's it. All right, this is question 2. It's very similar. It says, suppose we have the function f of x is equal to, we see the b to the x power here, but we also have an a being multiplied by the b to the x power. So it's a times b to the x power. And we're given 2 points. It contains 2 points, 220 and 6, 48. And then it says, well, what is a and what is b? So this one actually requires 2 equations because we have 2 points. And so what we're going to do is, for this one, we're going to put the 2 in for x right here. And then we're going to put the 20 for f of x. So we'll have 20 is equal to a times b to the 2nd power. We'll do the same thing here. 6 is the x, so we'll put that up here in the x. And 48 is the f of x, so we'll put that right here. And we'll write them both. And so we'll have 20 is equal to a times b to the 2nd power. And then for the other one, for this one, 648, we'll have 48 is equal to a b to the 6th power. Okay. Now what we'll do is in this first one right here with the 20, we're going to solve for a. And in order to solve for a, we're going to divide by b squared on both sides. Okay. And so we'll have 20 equals a times b squared. Then we'll divide by b squared on both sides, b squared. And it's going to cancel the b squared on the right. And we have a is equal to 20 over b squared. So a equals 20 over b squared. Now what we're going to do is we're going to take what a is equal to, 20 over b squared, and we're going to put it in place of a in this other one. So we'll have 48 equals a, which is 20 over b squared. So 48 equals 20 over b squared times b to the 6th power. Now we can put the b to the 6th power in the numerator with this 20. So we'll have 48 is equal to 20 b to the 6th power over b squared. Well, b to the 6th power divided by b squared, we can get that by taking the 6 and subtracting the 2. Okay, so that's the same thing as b to the power of 6 minus 2. So that is 20 b to the 4th power. Okay, so that simplifies. So we have 48 is equal to 20 times b to the 4th power. If we divide by 20 on both sides, we will get 48 over 20 is equal to b to the 4th power because the 20s cancel over here. Okay? I'm going to bring that over here. So we'll have, I'm going to switch it around. B to the fourth power is equal to 48 over 20. Now you can reduce this 48 over 20, but you don't have to. So now what we're going to do is we're going to put parentheses around both sides. So b to the fourth equals parentheses 48 over 20. Now we're going to raise both sides here to the 1/4 power so that we can cancel this 4 on the b. So both sides to the 1/4 power. And so 4 times 1/4 is 1. So this is going to become b to the first power, but we're not going to write the first power. We're just going to write b equals. And now we just need to find out, well, what is 48 over 20 in parentheses to the power of 1/4, 1 over 4. And let's go to the calculator for that. So 48 over 20, so parenthesis 48 over 20, close the parenthesis, to the power of 1/4. And it says that that is 1.245 if we round. So this 6 will round this 4 up to a 5. So 1.245. So B is 1.245. We'll put that right here. 1.245. Okay. Now we want to find A. But you'll see over here that A is equal to 20 over B squared. So we need to know B first, and we do. It's 1.245, although I'll show you in a second that it's not a good idea to put a rounded value in. So we're going to say A is equal to 20 over B squared. And so that means A is equal to 20 over, now we could put in 1.245, but like I said, it's a rounded value. So let's go back to our calculator. And you can see that it's actually 1.244665955. Maybe we can stop at 1.24466. We'll stop there. So what we're going to write is we're actually going to say 1.24466. And then we're gonna, is that right? Actually, that would be a 7. 6, 7. There we go. And then we'll square that. And then we'll put this in the calculator. Okay, so 20 divided by 1.24467 squared. And that gives us 12.909. But this here, this 9, this 8 is going to round this 9 up to a 10. That's going to make this 0 become a 1. And this 9 is going to be a 0. So it's going to be 12.91. So A is about 12.91. Okay? And that's our solution for question 2. All right, so question 3 is saying that the graph of g of x, this is g of x, which is e to the power of x minus 2, quantity plus 3, that this is the graph of f of x, which is just e to the x, shifted either left or right and either up or down, and we want to know how far it's shifted left, right, up, or down. Well, let's remember that the left and right shift always goes with the x, and so this says x minus 2, and so we know that a minus 2 on an x, it means a rightward shift. It's the opposite of what you would think. I know minus would be left. You would think it to be left because it's negative, but remember, it's the opposite. So x minus 2 indicates a rightward shift by 2 units. If it said x plus 2, then it would be a leftward shift, but it says x minus 2. And then this thing on the end, this plus 3 on the end, that means that's the vertical shift, and it's plus 3. And it's what you see is what you get. So it's, since it's plus 3, it's up. So that's up 3 units. Okay? So that's all we had to do there. Then it says the domain of g of x is, well, g of x is an exponential function. And all exponential functions have a domain of negative infinity to positive infinity. So that's done. And then the range of g of x. Okay, the range of g of x is always going to be, so for exponential functions, base exponential functions, they're going to start at 0. So normally we would do bracket 0, comma, infinity. But if the function has a vertical shift, which this one does, this one's shifted up by 3 units, okay, then our range is also going to be shifted up by 3 units. So instead of being 0 to infinity, it's actually going to be 3. So whatever number you have here, this number, if it's a positive 3, then it's going to be positive 3 to infinity. If the number you have here is negative 5, then it's going to be negative 5 up to infinity. But we have a positive 3, so we're going to put a 3 here. So the range is 3 up to infinity, and that's it for question 3.